All right, let's have some fun.
All right, let me see here. So, so ARP, basically in a nutshell, we're looking at the mapping of layer 3 IP addresses to layer 2 physical MAC addresses. All right. And that ARP is basically broadcast is sent out, all 255s. And just like on layer 2, when the broadcast all Fs go out, responses come back. Okay. Packet comes in for, let's say if it has a destination address of 11111, router doesn't know who that belongs to. So it'll send a broadcast message out and says, hey, someone out here has the address or is the address of 11111. I need you to respond. Okay. They come back. This is me. I'm address 1111. All right. Router records that information along with that MAC address, where that device came from, and as well as the port, and it's recorded into the actual ARP table. So, like I said, ARP is nothing more than mapping layer 2 MAC addresses to your layer 3 IP addresses. And
Hey,
actually, I
real
think
quick,
yeah.
are we supposed to be seeing a visual, or am I just supposed to be listening? I'm kind of confused.
No, Dave's going to be sharing some screen in a minute. He's probably
Okay,
still,
okay.
yeah, he's probably still setting up in the background. And he probably used me to fill in a little bit of time. So I think some of y'all have probably seen, I know last night we were talking about MAC address tables on a router. So y'all probably seen a snapshot that I put up in there in reference to what that looked like, as well as the ARP table. Yeah. So I had a router, and like I said, I know I said that the MAC address table on the router wouldn't really look all that impressive. And like I said, so what I did was I took that snapshot of the MAC address table and the ARP table on that given router and stuck it up there on the in the growth and networking engineering section last night. And I think I stuck a layer 3 switch MAC address table. And I actually took a layer 2 switch and showed the ARP table on that, because that has some SVIs on it. So anybody got any questions on that one?
My bad, Claude. What's going on?
Right.
Yeah, I missed what you just did. My fault.
That's fine.
So what's going on, Twan? Yeah, we were just talking about the ARP table, the mapping layer 2 to layer 3.
Okay.
Yeah,
Okay.
that's what we were talking about.
Okay. I guess my question is, it's kind of stemming from what I asked you earlier, Claude. Based on the picture that you posted in the chat, when in real time, when an ARP request goes out on the network, or rather to that router, when it sends the when it sends that request with the source MAC address attached to it, if the table doesn't have it on there, it will send out a broadcast.
Yeah, so if the if the layer 3 device does not know where that layer 3 source, or I should say layer 3 destination is,
Yeah, destination problem.
yeah, that's when it's going to ask. That's when the broadcast of 255 goes out. Okay. And is pretty much asking, okay, who has IP address ... whatever.
Mhm.
Okay. And somebody's going to respond,
Right.
because all those who don't have the IP address, they'll see the packet and then they'll just disregard it and say, this ain't for me. But the one that does will say, here I am, and I'm going to reply back to you, and I'm coming in on this port. And, the router going to say, okay, you're coming on this port, and, you're coming from this here MAC address. So let me go ahead and write this down at my table
Okay.
so that I'll know. So the next time I forward something, I know where to go. And see, you guys were seeing that last night when we were troubleshooting stuff and we were connecting things, and you see like that first dot, second dot, then it go exclamation, exclamation, exclamation. That's what was happening. It was that art process that was happening. That's those first couple dots were.
Okay.
Yeah.
I'm ready for some wire shot. What's going on?
So Claude, I got a good question.
Yeah. What's that?
Because I thought I know this activity is going on between layer 2 and layer 3. I thought that that it was a signal coming from layer 3 from the router, and it was looking for its destination, which is layer 2 and the MAC address. But is it opposite? Is it coming from the is it coming, I guess, is it coming from layer 2 and then looking in the router at where it's supposed to go?
Yeah. So initially, so you got that PC. If you can picture that the topology that we were working on last night, that PC coming from PC3. So that pack is coming across the wire with a layer 3 address on it. Okay. So it's going to go as far as it can layer 2 wise until it hits a router that either knows where that destination IP is, and it's going to forward it out that port to its next hop. And if it don't, that's when it's going to inquire, hey, where do I send this? Who has it?
Yes.
And that's when they'll find out. Okay. And then once it finds out, it makes its annotations in its tables, and then it continues to push that packet on to the next hop. Or if it's within that network segment, I'm gonna push it over here to this here host.
Absolutely. I see. I got it now. So it's coming from layer 3. That data is coming from layer 3, and it's looking for a hard coded address.
Yeah.
And it sends that signal out, are you here? And the responding, well, the one with the identity of the IP address where it's supposed to be, with the MAC address where it's supposed to be going, says, yes, I'm here. And then it sends it. Yeah, got it.
Yeah. So remember, Dave taught everybody that at layer 2, the source and destination MAC address changes, right? So when it goes to the next device, source, MAC address, destination MAC address, that changes. You follow me? In the header, and then it goes to the next device. Y'all remember that? Okay. The thing about on the layer 3 side, that same packet, the IP, that's not going to change. That's going to stay the same until it hits its point. Okay. And you've all heard the term echo.
Yes.
That echo request, that's nothing more than a ping. That's what that is. That's exactly what that is. But that IP address will stay the same until it hits its destination. And the MAC addresses, the source and destination MAC addresses, will change from each hop, from each device.
Yes.
Yeah.
So when it gets to that hard address, and before it moves on, that hard address at layer 2 rips off the shell.
Yeah. It decapsulates it, is what you're looking for. Yep.
Absolutely.
Yep. And they'll do that. They'll do that all the way until it gets to its destination IP. Because remember, that packet is going to be passing through multiple hops. And what's going to happen is those devices are going to look at that layer 3 and say, no, this ain't for me. Let me go ahead and send this on to the next spot. The next device says, nope, this ain't for me neither. Let me send it on to the next one. So when it finally does get to the destination, then that device, as you say, rip it out of the shell, it rips it out of that layer 3 shell, okay? Decapsulates it, that's what it does. It decapsulates, takes the information out, okay? The MAC address, it takes that information out, and then now you got the payload. Okay, what are you trying to tell me? And that's messages received. And then, you know, it does the same thing when it goes back. When that ICMP response goes back to the source. Okay, yeah, I got the message, blah, 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 confirmed, you know, and that's when you see the exclamations come up on, you know, when you do a ping test. Because it's done went to its destination and now it's coming back to me as a verification that, yeah, we got there. And actually, that's something that you can actually see if you were to turn the debugs on. There's a IP debug package or something like that, or IP debug ICMP, where you can actually see that echo request go out. And then you can see that echo reply come back. I may have actually a Wireshark capture of that as well. Matter of fact, I'm actually taking a look to see if I actually have that. Yep, sure do. So I'm gonna put this little picture in the growth and networking. And what you will see is the echo request going out. Yeah, here we go. Let me post that in there.
All right. Can everybody see my screen?
Yep, I see a Cali up there. Yep.
Oh man. Oh, this wasn't supposed to be here. Yikes. All right. Perfect. So, what's up, Angela? What's up, man? What's up, Jamal?
Hello,
Mr.
hello.
Security Plus. Oh, my man Patrick. What's up, man?
So,
What's up, man? Okay. All right. Here's the scenario. Again, we're going over Wireshark again. We are going to use Wireshark to try to understand. Again, this is just a refresher, right? We're trying to understand the path of a packet using Wireshark. Okay, we're going to look at all the layers of the OSI model, right, Patrick? So, PC on the left, is going to attempt to get an IP address. Okay. All right. You guys ready? Let's do it. PC doesn't have an IP address. Okay. So let's go ahead and force it to get an IP address. Okay, so it has an IP address, right? Now we are going to ping Google to make sure. Jamal.
yes, sir.
So the first step, right? Because what this tells me, right? I was able to get an IP address, but I cannot ping Google, right? Let's use Wireshark to understand why, right? So we're gonna go ahead and go to switch 2, right?
Okay.
And we're gonna promiscuously look at the traffic that's going on that port, right?
Yeah. Isn't that where you see all the traffic, right? Promiscuous mode?
That's correct. That's correct. So, getting a destination unreachable. Jamal, so
Yes, sir.
with that being said, what should I do next? Using the only tool that I have, which is Wireshark.
If you're pinging Google, that means Google servers might have turned off the ping, the echo, allowing echo requests. So,
Mhm.
man, it's crazy.
It's all good. All right, while you think about it, let me ask somebody else. Patrick, what should be the first thing that we do now that we have our tool Wireshark to go ahead and diagnose what's going on?
I'll say probably like look at one of the like frames or packet. Look at a packet that's showing, like open it up.
Okay.
Okay. Yeah, where?
All right. We opened it up.
All right.
All right. Destination private. Phone number.
Can I chime in?
Sure.
Yeah, go ahead, bro.
Yeah, I'm not too sure of the configuration, but one of the steps that I would do is probably do a trace route or find out where connectivity ends. So
Oh yeah, see where the hops
yeah,
at. Yeah.
yeah, see where it hops to and see where it stops.
You said only use Wireshark though.
Oh, okay.
Thank you.
Yeah.
Thank you.
My bad. I didn't know the configuration, so I'm just, I'm
Yeah.
just chiming in.
It's all good. It's all good, right? So this is how we're going to use Wireshark, right? We're going to go ahead and
Okay.
follow that path, right? Okay. So, Angela, what's up, man?
Hey.
Here. What's up, man? Okay. So, you're the star from last time, man. So, with Wireshark, right, we got a lot of things we can do, right? And it's just a tool. But with this information, go ahead and close everything. Okay. Angela, with this right here, what can you analyze just from that package?
We're able to we're able to see the source address, the destination address,
okay, so let's work through it together, right? So with Wireshark, right, let's read exactly what it says, line by line, right? So with using this, knowing that my gateway is 254, right?
Yes.
I am trying to ping Google 8.8.8.8, but this is telling me that the destination is unreachable. Okay, and we get a code, the host is unreachable. So we need to diagnose why. Okay, we're capturing the traffic promiscuously on gigabit 0/1. Okay, keep it real simple, guys. Okay, when we're looking at this.
I don't know none of that.
So now, it's all good. It's all good. It's all good. And I'll stop the capture right now, right? So one of the key things, right, just from the last time, guys, is your best friend is going to be the OSI model. So despite what you're capturing, you don't need to capture a packet for 20 minutes. There's no need. 30 seconds, shut it off. Okay? And we're going to use the OSI model. Okay? And so first we're going to look at it. Oh, okay, so we have our MAC addresses. Okay? And we have an IP address. So should we go ahead and look to see who these MAC addresses belong to? Wouldn't that be the good first step?
Okay.
Right.
Yes.
Yes.
Perfect. So Jamal and Angela, you guys are still here. So you guys are still in the hot seat. So Don't go anywhere.
Okay.
Go ahead and pull this up. Okay. And Brian, you're gonna be lead for them, okay?
I got you.
So Angela, so if I'm
Yes.
trying to understand, right, who's sending this traffic, what part of this packet capture, right, that I have down here, and let me, so you don't get, what part of the packet capture should I be looking for?
The source.
If I'm trying to find out the source, whoever's sending this traffic.
I'm sorry.
Think layer 2. Think layer 2. Think layer 2.
The data link, layer 2 is data link layers. Oh.
Now, can I jump in?
Source. The source.
Okay.
Source is always where it's coming from. Destination is always where it's headed.
Yeah, I don't know how that.
Right.
I had a brain fart right there.
It's all good. It's all good. That's what we're here for. So, like Claude was saying, OSI model, break down the packet capture, right? So
Yes, sir.
we're looking at layer 2 now, Ethernet, correct?
Mm-hmm.
It's going to show us the source and the destination. Okay.
Mm-hmm.
So whenever we're gonna, we're promiscuously capturing on this port, right? Gigabit 0/1. And it's telling us the source is this right here. Make sense?
Sure.
So, guys, I know, and of course, when you guys start working with Wireshark, it can look intimidating, right? Whenever we have all of these things open.
Mm-hmm.
It looks like it's a lot. I mean, who can't get overwhelmed? So this is why, again, you guys know the OSI model. Slow it down, break it down, look for what you know. Okay, I know what the Ethernet is. Those are MAC addresses. That's layer 2. Let's look at that first, okay? So we have our source, right? So now we're gonna go ahead and see, right? And see if that MAC address is on our MAC address table, okay? So let's go ahead and do that. So Jamal.
Yes, sir.
With that being said, and you seeing the screen, is that MAC address in our MAC address table for the source?
Oh, gotta make my phone. Gotta turn my phone sideways.
No, no problem. No problem. Let me go.
Is
Let me
that
go ahead and
is
zoom this
in your
thing
MAC
for you.
address table? Your MAC no. The source is 050. No, it's not. Yeah, it is. Actually, it is. Yeah, it is. Yeah, it is.
Okay,
Yeah, it is.
yeah. I was gonna say double check again.
Yeah, it is. Yeah, it is. It's number 1. It's dynamic, so that
Perfect.
means it's not changing.
Perfect. Okay, and our destination is who? Within
Your
our packet
destination is 50.50 semicolon 01. So the destination is not in there. I don't think destination is in there.
It's not in the MAC address table?
Oh, actually it is. You know what? It's messing me up. The semicolons. Sorry. So it's the semicolons
Gotcha.
in
It's
there.
all
Okay,
good.
yeah. So yeah, it is. Yeah. They're all the same, yeah. They're both.
Perfect. So now that we have that, right? And this is where your analytical skills come in. And this is where you're gonna have to reach on Angela for this, okay? Because she did great last time. And Angela, I know you can do this. With this information,
I'm so sorry.
you guys,
my kids are in the background yelling, so I had to mute myself.
Okay.
Sorry.
Oh, no
No,
problem.
they're good.
It's all good.
Hey, kids
It's
are
all
good.
good.
Yeah, kids are good.
Kids are good. It's all good. It's all good. So Jamal,
Yes, sir.
I'm gonna let you do this solo. And of course, you got Brian as backup.
All right.
With this
Okay.
information,
Ooh.
what can you analyze with this information? You have your MAC address table on your switch. You have your packet capture. What can you analyze with just that information? I don't care about us not being able to ping Google.
You can
Look at
kind
this
of use
information.
the CAM table to see which IP addresses correlate with the MAC addresses.
I want you to give me an analysis.
Oh wow, this is tough. Okay, well, if I'm trying to man, you can maybe the packet's being
It's all good,
forwarded.
brother. It's all good, brother. So both of us being engineers, let's work on it together, right?
Okay.
So
Yes, sir. Yes, sir.
we can do this, right? So
Yeah.
we know that the source of this packet is 0050.766, right?
Yes, sir.
Right. So that source is sending packets to 5001.xxxx, right?
Yes, sir.
Perfect. So we just analyzed layer 2. Okay. So we analyzed layer 2. Now we're gonna move to the next. Try to find out who owns these MAC addresses.
Yeah.
Okay.
Look at see which IPs correlate with those, right? That would be in the CAM table.
Nope. Slow your roll.
All right.
Still at layer 2.
All right.
OSI model. Okay.
Mm.
So, Kelvin, what's up, man?
Hey, man, what's up?
What's up, man? So me and Jamal are trying to troubleshoot this, right? Using the only tool that we have is Wireshark. We provide you our analysis, right? Who's our source and where we're sending it to, right? Via from a layer 2 standpoint, from what Wireshark shows us. The next thing me and Jamal want to do as engineers is try to identify who owns these MAC addresses. How would you do that with all the information that you have?
All right. Well, I'm looking at the MAC address table, and it's just based off the table. You know that from gigabit 0/1, that's the PC's MAC address that you learned from that interface. And if you look at port gigabit 0/0, you can see that that's the router's MAC address.
Perfect.
Oh shoot! I don't know gigabit. I got something game up.
So you can tell that source is calling to that destination.
Okay.
Right, and guys, so the key thing is, right, whenever you're analyzing these packets, because now a lot of things are going to the cloud, right? It's the reason why I wanted to go ahead and ping 8.8.8.8, right? Go ahead and slow this down and we try to make it simple. So I'm pinging 8.8.8.8, right? This is my gateway, right? So if I'm trying to ping that, what is this router going to do?
The router. Oh, go ahead.
It's going to route it, right?
Yeah, it's going to forward the traffic to the next hop.
Perfect. So, and we know, right, how ARP and how, things within the broadcast domain works. They're not going to forward that traffic beyond a, layer 3 boundary. It's going to stop there and it's going to do a packet rewrite at that router. So, with that being said, Jamal, I'm coming back to you. Be ready. With that being said, whenever we're going to go ahead and send traffic out, our last hop within our broadcast domain is going to be what, Kelvin?
The last hop that's in the broadcast domain, it's going to actually be the router.
Gotcha. Simple as that.
So anytime you ping anything outside of your network, the destination address is going to be the destination MAC address is going to be to the router, and the router is going to forward that, right?
Is that because they use PAT, right? I mean, network address translation, right? So it doesn't like pretty much promote your devices to the WANs, right? Is that why they do that? It's kind of like a security feature.
I'm thinking that
you're on the right path.
Yeah.
You're on the right path. Absolutely. I wouldn't call that a security feature. Claude's probably mad right now.
No.
But But yeah, Jamal, you're on the right path. So we use that to, of course, transform that packet to some other address that we assigned on that exterior interface, right? But here's the key thing. Here's the key thing that I wanted to show you guys. Wireshark is a tool, but it only can be used. You security people, your network people. You have to know the protocols that are flowing through. Very key.
Okay.
You can't troubleshoot something if you don't know how it works. That makes sense?
Yes, sir.
Yes, sir.
Cool.
Yeah, man.
Cool.
I feel like you just did. Not failed. Horrible.
Say it again.
So I feel like I had a technical interview just there, and I failed horribly.
Nah, it's all good, brother.
Yo, this is what this is for. This is the sandbox right here.
This is where you mess up.
Yeah, this is the sandbox right here. So don't even worry about that.
Absolutely. So with that being said, I think we have, because we started at 8:30, we have 30 minutes left. Jamal and Patrick.
Yes, sir.
Yes, sir.
So here's what I want you guys to do. We're going to analyze the packet.
Okay.
And I want you guys to give me the analysis. I'm going to keep it easy. Keep it easy. We're going to analyze a DHCP transmission between a source and a destination, okay?
Okay.
Dynamic host.
See our DHCP server.
Okay. Yeah.
See our PC. I'm going to give you guys the IP address of the DHCP server, okay?
Okay. So
the IP address of the DHCP server.
Okay.
You have that?
Yes, sir. 1.7. Yeah, 1.25. It's a class. Is that a class AA? Class? I can't remember class server is. Give me IPS.
No, don't worry about classes. Don't worry about classes.
Yep.
It's just a simple IP. Yeah, just a simple IP.
Yep.
Okay. Okay.
All right.
Okay. All right. And so, Patrick, you know the IP address of our PC?
Let me get that. I don't. Let me see.
I'm gonna give you a hint. It doesn't have an IP address.
Oh, okay. It means okay, cool.
Okay. So, what would that IP address be if it doesn't have an IP address?
If this is a Mac, I mean this is a Windows PC.
It's a PC in general.
It wouldn't have one. I mean, it'll be a PIPA if it was like a Windows, I would assume. Like a PIPA address.
Let's say a PIPA didn't exist.
I never heard it. I thought all PCs had IP address.
So it's all good. It's all good. This is all a trick question, guys. So it would be, right, if it doesn't have any, keeping it simple, doesn't have any numbers assigned to it, it'll be a 0.0.0.0/0, right?
Okay.
Doesn't have an IP address, doesn't have a net mask. Windows, of course, have their own features, but keeping it simple, doesn't have an IP address. It would be a 0.0.0.0. I want you guys to remember that because we're gonna analyze these packets. Okay.
Got it.
Make sense?
Mm-hmm.
Okay. So here's what we're gonna do. We're gonna follow the path. We know where our DHCP server is. We're gonna set up a couple of captures. So we have Brian capturing here. Okay.
I had a quick question for you. So there's the packet. So just making sure, does the packet captures start in Wireshark once you run a command from command line, right?
It can, yeah.
Okay.
And we're gonna have Samir, being the PC tech down here, analyzing the packets right next to the DHCP server since he's over in that building. All right?
0.0. Okay.
I'm gonna analyze we're gonna have Antoine analyzing the packets here, right, before the router. So Brian's on one side, Brian's on the WAN, Antoine's on the LAN.
Just when I thought I knew some shit.
So, hey man.
I got a question.
Goddamn. Yeah, go ahead.
So what would that what would interface that would be the ingress or the egress?
In regards to what?
How the traffic is flowing. So for example, if a packet is coming from instead of if it's coming from PC3, was that PC3?
Mm-hmm.
I'm sorry, yeah, PC. Yeah, so if a packet is coming from PC3 to the Linux PC, right? Would the interface GI 0/0 on router 8? I think it's 8.
You saying from 9 to 3?
Nah, from 3 to the Linux PC.
The first, he's talking about the first router.
Oh,
The first router, gigabit interface gigabit 0/0. Would that be the ingress or the egress interface?
Dude, that's first thing first, bro. That's a good question, because I know, and I'm sure everybody's heard, that's ingress and egress is a big word that's used a lot in the industry. So you got to know how, what it means, right? So ask Patrick. You said what happened?
Oh, my bad. I was talking to myself. I think, is that ingoing and outgoing, inbound, outbound? Is that what it is?
Yes. But yeah, you exactly on the right path, right? But here's the key step, right? I told you and Patrick, right, to keep in mind your source and destination. So ingress and egress, it changes depending on who's your source and your destination. Here's what I mean.
Right.
Here's what I
and
mean.
doesn't it also impact the port as well that it's coming from too? Like, because it can be one router, but that interface is the ingress, and then the outer interface where exits will be the egress.
Yeah, see, you're going into multiplex and doing multiple sessions at one time.
Yeah.
So that is true. Yeah, but just for simplicity's sake here, we just gonna be picturing one packet going through at a time, and even though this could be a massive network, we're just going to send one packet. So this traffic is going to be going one way at a given time. So
exploded over here.
Yeah, so let's just look at it that way. Let's just look at it that way. Okay.
Gotcha. And just to clarify.
So guys, so does that make sense?
Yeah,
that makes sense. Okay. And I guess my interface is router. The first route on the first interface, the first router. I got confused with the green arrows. My fault. The first router.
I'm gonna help you out with some visuals, okay? And
Great.
We'll get back to this packet capture.
All right.
So let's say the starting point, green, is our Linux PC, right? Just like you said. Okay. Everything flowing in this direction to router 8, right, is egressing the Linux PC. Because again, we're going with the direction, right? But it's coming in, right? It's coming in to switch 3. That's ingress. Okay. It's leaving switch 3. Egress. Exiting. Okay. Same thing all around. Now, if we switch directions, right, with you knowing that, when it's coming back from R8 and it gets to R9, and R9 is pushing it to switch 3, Twan, what type of interface would gigabit 0/0 be if it's going down to the Linux PC? Would that be the egress interface or the ingress interface?
That would be an ingress.
Why?
Because the traffic is returning back to the Linux PC.
No, I want to
instead of it being pushed out.
Close.
Yeah, it's
exactly. Guys, remember, ingress and egress is in respect to the direction of the traffic. That's it.
So it would
Keep it
be
simple.
it would be egress.
You know what's a
It'll be
good way to look
it'll
at
be
it,
egress
Antoine?
out of R9.
Okay, cool.
That's why you know
Wait,
what's a
so
good way to look at it?
can we use E for exit? Like egress is exit, the ingress or
Yep.
whatever, you know, it's in
Yeah,
coming
Or
come
in.
just use
come on in.
in and out.
Inside. Yeah.
In and out.
In,
In and
yeah.
out. In and out.
There you go.
In and out.
There you go. There you go.
Egress, exit,
All right, cool.
inside. Perfect.
So, but does that make sense, Twan and everybody? Ingress,
Yes,
Yes,
egress?
sir.
does.
Yes, it does.
I actually want to make sure I got it right. You asked Twan about the one that was coming into the switch that's right before the Linux PC. So you asking about 0, 0. So that would be, is that ingress, and with the other interface, the G1/0 on the other side of switch 3, be the egress since it's coming out that way, going to Linux? Was he right with the ingress being a 0/0 interface?
Yeah, so if we're going in the direction of red,
The
right?
red.
So if it's coming from R9, it's coming in, right?
Right.
It's coming into switch 3, right? So what would that
Right.
be?
That's ingress. It's coming in.
Okay. So but it has to get to the Linux PC. So it has to exit gigabit 1/0. So what type of interface would that be?
Egress for the 1/0 on the
There
other
we
side.
go.
Okay, perfect. I was gonna make sure. That's good.
It's all
Yeah, I
good.
won't
It's
believe
all
I
good.
just
Good
kind
stuff.
of. I gotta go look that up later. Egress, because I'm like, okay. Yeah.
It's all good. It's all good. So now the moment of truth. Maul, Patrick, you guys ready?
Yes, sir.
Mhm.
Yes, sir.
Where is that?
It's a loop. Flattening to cables. Cable for the two devices, two switches. STP. I forgot STP. This some protocol, spanning tree protocol. DDP. What the fuck? Yeah.
Okay, perfect. So let's go ahead. Try to get an IP address. Oops. In annotation mode. There we go.
And watch those colors change, y'all.
Dave, why I feel like this some of this stuff look familiar in here, like you just do you like it's some of this stuff that we done seen.
You
But
have.
it's just basically from the even G level and not necessarily seeing it this way. Because I'm just seeing STP and loops.
We'll get to that. This is part of
you've seen this stuff, Brian. Yeah.
Yeah.
This is
just
seen
part
this
of
stuff.
the troubleshooting
Yep.
process of using
Gotcha.
Wireshark. So keep
Yeah,
following.
that's all.
Hold on. Okay. I think I see something. I'm not sure.
We're gonna have to start the
Hold on,
packet in
Twan.
order to
So we will. Twan, give it 1 second, okay?
Mhm.
So I need Jamal and Patrick. Y'all ready?
I guess we can stop. Yeah, 22443. I gotta remember these MAC addresses.
It's all good. It's all good. We'll get to that. So
Okay.
I'm gonna go ahead and stop each packet capture. Perfect.
Okay.
So this is the LAN interface 0/0 on RA. Okay. This is the WAN interface on RA. This is interface on switch 6. Okay. With that being said, from what you can see, Patrick and Patrick and Jamal, and you guys can again shoot out the answers from what you see on the screen, and let me know if you need me to extend the Wireshark captures. What can you analyze using the OSI model and looking at the Wireshark caption?
Okay, so from what I see here is I'm looking at the Ethernet 2 tab there. So the MAC address of the 6801 is PC1. It's sending a broadcast with as we see the all Fs. So it's saying,
Okay.
it's shouting out, hey, hello. And I also see where it says DHCP at the bottom, where it's pretty much the DHCP protocol, and that is it's in the discover phase. So it's trying to, I guess, discover the what do you call it, the DHCP server.
Perfect. Damn, that was good. Okay, Jamal, let's go to the WAN side. What analysis can you form by looking at the information that you see in the packet capture? Keep it simple. And again, we're here to help, so you don't have to figure it out on your own. Just go use the OSI model. Start at layer 2.
All right. Shit.
I help, brother.
They're only going. Wow.
David, can you bring the VPC box down a little bit, please?
Uh-oh. She's here, y'all. She is here.
Hey, I ain't think we could tap in. I was gonna ask that.
I'ma try. They lit over here. They giving me a run for my money right now. So
okay,
it's all good. So Angela, hold on, Jamal.
Yes.
So I'm gonna bring you in some help. I'm gonna call Claude. What'd you call it? What is Veronica from Iron Man? Whenever he calls down his new suit. So we're gonna call on Angela. So Angela, you doing so great last time on this Wireshark. From what you see, the same question I asked Jamal. What from your analysis, what can you muster up from what you see here? Only with the information that you're given.
The device, it knows the destination of the DHCP server at this point because it has the source IP address and then the DHCP server IP address as the destination.
That's one. Excellent. All right, keep going. Brian. Good stuff, Angela. Brian, what else? You already tackled layer 3. Talk about the other layers for me. What can you analyze from this package?
So you're looking at the MAC addresses, the source MAC and the destination MAC address. So you need to do show MAC address table to see if those two are showing up in that table. Looking at the two MAC addresses being the source and destination is what I see from here.
Perfect. Okay. All right. Excellent. So, last but not least, Kelvin, there's one thing that's sitting here that should give you guys a hint. What else can we identify just from the information that we see?
They're using the same.
The source and destination ports. Are you not worried about it?
You're getting close.
So
what else at layer 3?
Discover protocol.
Close. What else at layer 3 can we identify here?
I mean, let's see, anything with layer 3 I see is using IP version 4 source and that had the source and destination IP addresses.
Can I say something, David?
Go ahead.
What I'm thinking is the source address changed. Well,
yes,
the source address is now router 8.
Router 8 what? Keep going. Router 8 what? Keep going.
It's the interface of the G0/0.
Yes, keep going. Keep going.
And because of that, it's not going to change like the source MAC or the source destination, but on layer 3, since it's now traversing it's no longer going to use if it had an IP address of Ethernet, PC1, whatever. It's now the source IP. So now that it's the source IP, it's going to say, hey, do you know this address? Because it's going to pretty much point to that outer interface 0/1. And now that it's in that network or that segment, I'm assuming that it has to communicate with router 9 now, and router 9 is going to say, hey, I know this 172 address because I'm seeing router 9 down there where the 172.16 is saying,
Okay.
I know someone on my interface, on another interface that knows this this address. So I'm going to go ahead and push it throughout that interface.
Okay. All right, Patrick, you're not. Yes.
I don't know if you guys mentioned this already, and I'm not sure if should the source and destination port be the same? Should they both be port 67?
That's a good point. That's a good point. Guys, let's keep rolling. We're still not done because somebody still hasn't said it. Patrick, you're close. You're close. Think about what you just said. Has to do with DHCP.
Is it the IP helper?
Everything that Patrick just said. Keep going. What can you analyze knowing the DHCP process, looking at that packet? Everything you just said, Patrick, think about this.
Destination source. Okay, it's going to push 25.
Could this possibly have anything to do with art?
Nope. We're at layer 3.
Okay, cool.
Is it the default route? Is saying, hey, I don't know this address, so I'm going to send it to router 9.
So, Patrick, you're close. I'm going to help you out, okay?
All right.
And guys, great job on analyzing this. Patrick was definitely the closest, right? So, just from what Patrick had, okay, let's look at this. He explained that router 8 was a DHCP relay agent. How did he explain that, right? The PC doesn't have an IP address. We confirmed that, right? So what happens is whenever that DHCP discover message is sent out on the wire, it's a broadcast message, right? And it's trying to reach out to whoever the DHCP server is. If it's not on that local area network, right? The only way that DHCP discover message can get to the DHCP server that's not on the network is a DHCP relay agent needs to be set up, right? And all it's doing is relaying that discover packet via layer 3, because that DHCP discover is typically a broadcast message, okay? So how the DHCP relay works, we can't send a packet on the wire without an IP address. So we can't send packets saying 0.0.0.0 because we can send it to the DHCP server, but it doesn't have a way back because we don't know who this is, do we?
No.
So with that being said, what happens is the DHCP relay agent, it rewrites the packet. It says, okay, so I'm gonna go ahead and take care of this packet for you. And I'm gonna go ahead and give this packet the IP address of that interface. And what it's doing is, what that DHCP relay agent is doing as well, the IP helper address command is saying, this is the IP address of the DHCP server. So now what's happening is the router is saying, hey, here's the IP address of the DHCP server. Now I can go ahead and put that in my destination. So with that being said, Angela, Patrick, and myself can come up with and say, hey, looking at this Wireshark capture, we can go ahead and analyze that the source, like Patrick was saying, is the LAN interface of router 8, and the destination is the DHCP server. That's it. That's it.
Got it. And can David, can you just clarify again on how it knows what the 1.6? So there's a router on router 8. We already know that the DHCP server's destination address. So if the router was not configured, obviously for it won't do it, right? It won't. So the helper address, is it saying, hey, this is literally 172.16.1.25. So when we do the IP helper address, that is the address that we're putting in that command, or is it like the network itself and then it figures it out?
No, exactly, right? Because it's just like, let's say Patrick wants to send mail to Brian about Bandcamp. Okay, you're at PC1, right? Let me get my little handy dandy drawer. You're at PC1. Okay, so you're trying to send this to Brian, but you're nowhere near Wisconsin, right? So
got it.
With that being said, who you have to give it to get it to Wisconsin?
Gotta get it to the router, right?
Got to get it to the post office, right? And they'll take care of all that stuff. They know where Brian is. Hey, we know how to get to Wisconsin. Okay. So then what's going to happen is that package now is going to come from the post office and get all the way to Brian.
Got it.
Does that make sense? Cool. We're at 9:26. Guys, any questions? It was good.
I ain't gonna hold you.
A whole lot in this.
I ain't gonna hold you. I feel like I just took a Spanish course. All that sound like all that sound like Spanish to me.
Bro, it was good all the way up until it got to the point where that curveball came in with Pat, and I was like, oh shoot. Like, and he went like real in depth. I was just like, okay, this connection after connection after connection. That's just I see what I'm reading in the Wireshark, but
yeah, like see, I've dealt with Wireshark in my graduate program, but we only scratched the surface. Like we did 1 or 2 labs.
And I say the same thing. I say the same exact thing.
We didn't really get like too heavy into it. So like I was able to like, play with it for like maybe 2 weeks, and then they like you can't do it no more. They had to cut the labs from you. So like I know what Wireshark is, but I'm not gonna lie, I feel like I just need to sit in the back of the class, and I'm just gonna put my head down and just watch everybody do their thing.
Well, see, the thing about it is like if you brother. The thing with this, how everything was explained here. So I've seen Wireshark before, and just knowing about like in the field that I'm in, like knowing source and IP, it's like source and destination. Like looking at those and comparing those to an actual physical environment that you could see and actually put your hands on here is a lot easier than you looking at, okay, just, oh, this is the source IP, this is the destination. We're gonna see what IP, is this a good IP or a bad IP? But this Wireshark actually, tonight, I learned a lot more now. I think until I got to that one point, but everything just based off the knowledge that I have about source and IP, and now learning ports and protocols and APTs, like it's starting to break down and make a lot more sense.
So question, like, because I'm be studying for my CCN, would I like start learning that stuff from the ground up, or do you have to like know a lot of stuff before you jump into my CCNA? Because I bought the books already, but I feel like so you can go from ground up.
Yep, you can be a complete beginner.
Okay, just make sure. Because G/0, I had never seen this. I was like G/0. I was trying to find it.
That's the gigabit. So that's basically the speed of that link, that connection.
Okay.
And guys, here's the key thing before I let you guys go. Right? It's one big thing that Patrick and Angela did tonight. Guys, keep it simple. Use your wits. Okay? Look at the diagram. Look at the information that's in front of you. Okay, let me put 2 and 5 together. If you see people on the street, you walking in the street, they're shouting at each other. What are you going to analyze? What is your analysis, Jamal? If you see 2 people shouting at each other.
Oh, they're arguing.
Boom.
Yes.
That's it. That's all Patrick and Angela did tonight.
Mm-hmm.
That's it.
Mm-hmm.
Does that make sense?
Right.
Yes, sir.
Okay. All right, guys, next session. I'm giving you guys a brief hint. I have my little handy dandy Metasploit up. Be ready.
Oh, I know about
Get some
Metasploit.
dirt.
I'm familiar with Metasploit.
I'm
Meter,
gonna-
Peter, all that.
I'm gonna do some dirt. So, guys, great job, and you guys have a great night, man.
All right, good
All
night.
right, good night, guys.
Thank
See
you.
y'all.
Everybody did a good
Nah,
job.
everybody.
Y'all did good.
Yeah, great
All
job,
right.
team.
Great job,
See
everybody,
y'all.
man.